on this computer. Okay, nice to see you all here. ITS128, and it is January 24th, and so we are. Let's see where we are. Let me share my desktop with you. And let me put this down here. And let me close this. Let's see, overview in ITS128. We are in the middle of chapter 3. So I'm gonna wait till next week to give assignments. Give my assignments to guys because I want to grade some of your stuff, and I want to see where you are. For those of you that have handed stuff in, of course, there's stuff's not due yet. So, but there's a few of you have handed stuff in, so that'll give me a good chance to see if we're on the right track and get you some feedback. So let's open up this. Let me open up the book here. Now let me just open up the slides. Let's see, resources. By the way, just so everybody knows, this actually, if you're watching this video, you know this already, but all the videos are in this class videos. Okay, so if you don't know how to do something, you can first check there. Let me put the slides. Let's see, we are in chapter 3 still. Yes. So let me bring this down here, save it. I'm going to save it. I probably have it there already. PC, space, Halverson. Oh, look at, there we are. Let me just bother with this then. And I wonder how far I got. I can't, let me just check and see how far I got here. How do I do that? Let me go to the class videos. And it's this one. All right, this is ITS 128. It is. So the rules of variables you can assign, rules for performing calculation. You type in 1, 2, 3, 4. If you type in 25.65 into the text box, it's 20. Concatenated with playing numerical values. 21. We're halfway through here. 22. I think this. We spend 4 class periods on chapter 3. Okay, 22. Great. So fantastic. Let's go to 22. All right, let's start with 20. Inputting and outputting numeric values. This is, I'm just going through these slides, so I'm probably not going to do too much. Well, but let me pull up Visual Studio just in case I want to demonstrate anything. Visual Studio, VISUAL Studio. While that's starting up, let's get started. Input, okay. Okay, so inputting and output numeric IOs. Inputs are collected from the keyboard. Inputs collected from the keyboard are considered combinations of characters or string literals, even though they look like a number. A text box control reads the keyboard input, such as 25 period 25, 65. However, the text box treats it as a string, not a number. So if you want to, if we do a quick search here on ASCII character set, looks like this. This is a nice ASCII character. Here's, you know, when we see 25.65, we're actually seeing the character 2, which is this here, and that would be, you can think of it like the number 50, or you can also think of it like the decimal number 32, which here, let me put this back up. So 2565 actually is like, excuse me, this is not working right. It's, let me, um, 25.65 is actually the character. It's actually the character 2, which is equal to the number. It's actually equal to the character code. What did I just do? Character code 32. 32. I'm looking at this hexadecimal number here. 32, which is equivalent to binary 0011 0010. That's a 2 in binary. That's how the computer stores the 2 character. And 5 would be 00110101. That's 5. A period is actually 2E. 2E is 00101110. That's 2E. And then we got a 6, which is 6. You don't have to know this. You'll never have to know. I'm just trying to explain stuff to you. 00110110, and then we got 5 again, which is 00110101. Okay, this is how when you type in 25.65 into a text box, and then the computer, and then you execute, why is this so big? You execute something like this. Let's say you type 2565 into this hours worked text box 1 text box, and then you do this int parse. Let's do a temperature box. Okay, let's say you type 25.65 into the temperature box, text box. Really, what you have typed in is this. And this is the 2 character. This is the 5 character. This is the period. So you've typed in 5 characters, and these are the codes inside the computer. The computer just sees those as those codes. But then when you do this this double parse thing, it takes those character codes and says, oh, we're parsing this. Oh, it's a double parse. Well, that means this must somehow convert into a double number. Well, 25.65 can store into a double type number. So it converts it into whatever 25.65 is in binary, which is a bunch of 1s and 0s, but when you convert it all back, it ends up being this value, and then that's what's stored into this double value right here. So the idea here, and folks kind of have a little bit of trouble grasping this concept that although what you type into the text box looks like a number, it's not really a number. It's just a string of characters, and in fact, in C#, you need to actually tell it that you want to convert it into a number, and also the type of number. It's a double number or an integer number or a decimal number. Remember, there's different kinds of numbers in visual in a C# also, and for those and us academics who teach programming languages, we think that having you making you have to do all those things, like we're going to convert this into a number. Don't try to use the characters like a number, because it's not a number. You have to manually do it, and you also have to manually know what kind of number it is. We tend to think that's good when we're teaching programming languages, because it forces you it gives you a certain rigor. It forces you to really understand what's going on, and if you don't really understand what's going on, the computer tells you, I don't know what you mean. It says something like, I don't know what you mean. Whereas other programming languages like Python, oftentimes the computer is smart enough to say, okay, he's got these characters here. He's got a 2 character and a 5 character and a period character and a 6 character and a 5 character, and he's trying to add it to some other number. Well, by gosh, if you look at this closely, this could be a number. So then the computer automatically changes it over. The computer's got to do it. You have to change the string of characters into the actual number. So the computer's got to do this something like double dot parse. But in many programming languages, because it's so obvious, to the human, it's smart enough to be able to just do it. Now, the reason that we don't like teaching programming languages that are quote lazy like that is because you end up being lazy programmers. Well, of course that philosophy is changing, and it's good to actually learn both. And there's also a thinking now that maybe we should start with the lazy languages, so you get the programming part down. So you get sequences, and you learn about the loops and the if statements and all that, because all programming languages have loops and if statements and while statements and all that kind of stuff. But then after that, should you happen to find yourself in a large software company, and you got 100 people working on one single software project, and you all have to write code that connects up with other people's code, then it's very important that you really know what you're doing. And if you're at that stage and you already know a programming language, then just learning to be more specific and more rigorous is just one more step. So anyway, yes, you have a question.
So you would recommend lazy programming languages for those who are not going to like more in-depth professional programming professions, like a person like to learn Python just to know how to do something?
Well, more than that, there are lots of programming jobs where like that's what you're going to write program in Python. Like if you're doing something like there's like IoT, which is like computers in your refrigerator, computers in your microwave oven, computers in your television, and they all kind of talk to each other, and you leave the house and all of a sudden the thing wakes up and it sees, oh, he's not around anymore, or it knows that you're running out of milk or something. Those would be just Python. You're not going to write that code in C#. You don't need to. Again, it's like one person is going to write that code. It's not going to be a team of people that writes the little code that operates the microwave oven. And there was a lot back in the old days. I mean, I worked on a project once where we were writing a little controller for a washing machine, and yeah, it's just one guy writes the thing. So, then the simpler programming languages where you can whip code out fast, those tend to be better. Now, the other thing is that if you master a language like C#, okay, then you go to a lazier language like Python, you're a pretty good programmer. Your code usually works right away, and you aren't stuck with errors that you scratch your head. You don't know what it is. I mean, lots of times when you're a Python programmer, something doesn't work, and then you just start trying stuff, and then you finally get it to work, and that's great. Your boss says, "Oh, good job." There's different philosophies on it.
So start hard and then.
Yes, and the reason that the other approach is we're looking a lot more at the other approach is there are people who come in and programming or this IT stuff, this like DLT, this language, it's not all programming anymore. When you talk about computer security, and there's a whole big area, computer security and all these other fields, you aren't coding. You know about coding. You know that people write code, the languages, but what they're doing is they're sticking stuff on the server, and then they're going in and infiltrating the system, and that it's not the fancy algorithms. It's, oh God, they got in there. There's a leak, or there's a hole there where they can get in. There's a security breach, and so there it's a lot less important that you understand the algorithms. Those programs are also not big systems. They're little patches of code that are stuck in someplace, and so the paradigm is changing. But so we may end up leaving some people behind when we take this approach. But there are other, we do teach Python and those other languages, and so. And my approach to 128 and 148 is that a lot of you are taking these two courses not because you're going to go out and be hardcore programmers and go work in a big software environment. You're taking it because you want to learn it. You want to learn about it. You want to learn about the people that do it, what they have to go through. But man, you don't want to have a job where you got to spend the next 4 weeks or something trying to write code that's got to match up with 3 other people's code and so on. So so we don't want to ruin anybody's future here in these 2 classes. And you can be the judges of whether or not you want to pursue going into 228 or go off into some of these other more fun languages. I wouldn't consider C# a fun language. You got to write a lot of code. You got to get everything right before you get stuff to run, and it's usually just on the Visual Studio development system, so you don't see much more of that. Whereas when you get later on, you write Python code to make the robot do Tai Chi. That's more, you just write a little bit of code and okay, it's doing this, and write a little bit more code and it's doing this, and so anyway, that's where that's at. There's a little bit of a tangent there. So anyway, so here we are. Displaying numerical values. Okay, this is going the other way. Okay, we take a number and then we want to display it out either in a label on the form, or we want to display it into a text box, or we want to make it display up in a message box. Well, if you just try to write, if we were here we're taking some value gross pay, and it's equal to 1,550, and we want to display that into a text box, a label. We want to write that into a label so it displays up on the form. We can't just put, display out 1,550, because it's going to end up being some gobbledygook. It's going to take 1,550, which is probably 2 bytes. Maybe that will equal probably about 2 characters, and 2 ASCII characters, two of these somehow, and that's what you'll see displayed up, a couple of gobbledygook characters. Maybe if you've ever seen your computer crash or something, and the computers don't crash like they used to, but all of a sudden you get the Microsoft blue screen, and there's all these gobbledygook characters on there. Well, that's what's going on. It's displaying out some contents of memory. And it's not a bunch of nice characters. It's not a bunch of these nice ASCII characters. It's some big numbers which end up translating into some sort of characters, and that's why you see that. And so this is going the other way. You use this toString method, and the way you do the toString method is you take the number that you want to display out, and then you attach on this .toString method call. If it has parentheses after it, you're calling a method. You're calling a function that's going to do some operations before it's done, and that's what that does. And then what this is doing is converting the value that's inside this gross pay variable into a series of characters that looks like the 1 character, the 5 character, the 5 character, the 0 character, the period, and the 0 character. Okay, not this M. This M is just to indicate that this is a decimal number instead of another kind of number. So that's what that does. And here we're displaying out this my number value out. The message box displays up in a message box. And then, so that's how you explicitly convert a number to a string. Now, some numbers, there is some laziness to C#, and this is an example of a laziness, because we're taking a number here that's a number, but we want to treat it like a string. We want to treat this number like a, just like a 1 character and a 0 character and a 4 character and a 4 character. That's what we want to treat this as. And in this case, it's so obvious because we're writing something into a string variable. We're starting with a string, and then we have a plus sign there. And if we have a string and a plus sign, this plus sign does not mean add 2 numbers. It means concatenate 2 strings. Take this string here and concatenate it with some other string. Well, in that case, there's the overwhelming evidence that this is meant to be a string. So you don't need to put the toString after it. You can, but in this case you don't need to. So that's implicit string conversion. There's not a lot of implicit stuff in C#. In a language like Python, there's just implicit stuff all over the place. It's not these weakly typed languages, weak WEAK, I say they're lazy languages, but it's pretty obvious. I mean, it's not really sloppy. Where it becomes sloppy is if you in C# you always have to declare a variable before you use it. And in Python, just using a variable declares it. So, and also in Python, if you use a variable inside of an expression, it's going to not only declare it, but it's going to assign a default value to it. So in a language like Python, if you misspell a variable, if you're using a variable and then later on you want to use it and you misspell it, it might not alert you. It might think you're declaring a new variable, and you don't know. You know, you've made a mistake. You spelled something wrong, and you don't know, and your program doesn't work. Sometimes you don't know your program's not working, and that messes things up. Whereas in C#, it'll say, "Wait a second, what is this? This is not declared," and then you go, "Oh, I spelled it wrong." And usually, when you're starting out programming, you spell things wrong quite a bit. So here's when we use this toString method to convert numbers into strings. There's many ways to format numbers. Yeah, I mean, here for example, we have this number 12.3, and we want to make it a string, but we want to have it be we want to have 3 decimal digits instead of just whatever it ends up being. So if you do this n, n stands for, n is short for number, then it's going to display out this number, but it's going to be 3 decimal digits to the right of the decimal point. That's why you see 3 digits here instead of just 1. F2 is scientific floating point number, not much different than a number format, although with a number format you'll see some commas. If the number gets bigger than 1,000, you'll see commas. In this fixed point, you don't see there, you won't see commas. It's just a number with a decimal point. And this exponential scientific format, you know, the e is times 10 of the, this is 1.235 times 10 to the 5th power. Let's see, 1.235 times 10 to the 5th power. So 10 to the 5th power means move the decimal point over five spots. 1, 2, 3, 4, 5. E, that's E. 3 is 3 just means 3 decimal. Here you're defining the number of places, and then it's going to put the E plus. It's going to make this E. It's going to put the appropriate E value there. C is a one we use all the time, because lots of times we have numbers like this, and it's money. We want to display it out as money. So this toString C takes care of it very nicely. And by this toString, you know, I'm talking about using like this, except for you put something inside there. That, you know, that's what we're talking about, something inside there. And so what the currency formatting does is it throws in commas. It puts a decimal point plus the cents, 2 digits to the right of the decimal point, and it throws a $sign in front of it. And if it's a negative number, it puts parentheses around it, just like accounting format. And then the P means percent. So it takes this 0.234, and you want it to be percent, so you multiply it by 10 or by 100, so it's 23% instead of 2.23. P will put the percent symbol after it, and 2 makes it 2 decimal digits. Okay, there's something called exception handling. We're getting into exception handling already. That's good. So in the old days, we never had exception handling. The program just bombed. But it was up to the programmer to write code to check stuff to make sure that it's not going to get into position where it might bomb. Like, what can make a program bomb? Like if you're doing a bunch of calculations and you end up trying to divide by 0, that's going to make the program bomb. You can't divide by 0. So in the old days, if you're going to divide by 0, if you're going to do some expression, it's got a division, and you're not sure about what the denominator is going to be, then the first thing you do is you test to see if you evaluate the denominator all by itself and see if it comes out to 0. If it doesn't come out to 0, then you can go ahead and do the division. If it comes out to 0, then you say, oh, I'm not going to do that calculation. Well, now you can create what are called exception handlers. And you can make an exception handler where instead of bombing, okay, so you take this code that might divide by 0, you take all that code and you put it inside of a try clause. Just try it, and if it works, great. If it bombs, then it's not. If it doesn't work, it's not going to make the program bomb. It's just going to make the try part bomb. The try part says, "Oh, can't go any further," and then it jumps down and it does the catch part. So the catch part is there in case the try part doesn't work, and that's a nice thing. That was innovation. I mean, so it's great that programming languages have that now, and so we use that, and programs can bomb all kinds of ways. Well, one way a program can bomb is if you are doing something like this, you have some number, and you want to convert. You have some text and you want to convert it to a number. All right, so what if you got something where you want the person to type in like a dollar amount. You want the person to type in like an hourly rate, and the person typing in the hourly rate says, well, this is money, so I'm going to put a dollar sign there. So the person types a dollar sign, 15, or maybe $15, $15. And then you try to do this try parse. You try to do, try to do a double parse, and it looks, and the first thing it sees is a dollar sign. The dollar sign is not a digit, so it goes, oh, this isn't a number, so it bombs. And so what you can do is when you read stuff from the form, like that you're reading some input that the user typed in, and you're typing in a text box, typing a letter, typing in a non-digit into the text box is illegal. You don't have any control over the user, but what you do have control over is your code. So you'll put the code that reads the user input, you put that code all inside of a try clause, a try block, and then if it's going to bomb, it just bombs inside the try, and then it jumps out to the catch, and then in the catch you put you display some message box that says, hey idiot, type in a number. So exception handling, it'll abruptly halt. And just in C# allows you to write code that responds to exceptions, such code is, I'm sorry, I'm an old time. Such code is known as called a try catch. The try block is where you place the statements that could have the exception, and the catch block is where you place statements as the response to when the exception happens. And so something like this looks just like this. So the user may enter in invalid data. Like, let's say you're supposed to type in, let's say it's a program that figures out what, miles per gallon. It's a program that figures out miles per gallon. So the person's got to type in, you know, some miles. Those would be, you know, some digits. And then you want to type in some gallons, which would be some more digits. And then you want to divide the miles by the gallons, and then you want to display it out. Now, what happens, there's all kinds of things that can go wrong here. You can make the gallons, they put in 0, they forget to put something in. You know, they put in something that's not a text box, or that's not digits. All kinds of things can go wrong. So you put that whole thing inside of a try, and then you have this catch thing, which if they do type anything wrong, it's going to display out this. Turns out that you can actually you can actually put this right after the catch, and this will pass back what the message is, the message from the try catch. So we got something here. Let me open up a new project here, and put this on the desktop for no other reason. And let's say we do, let me do a toolbox, pop this. Let's put a, let's put some labels on here. Miles, gallons, miles per gallon, miles, gallons, gallon. And let's put the text box here for this, the miles there, the gallons there, and we can just put another label here to put the results. And so these things I want to name because I'm going to refer to them in my program. I'm going to read from this one, and write to this one. So I'm going to name this one. Go find name, find the name of it. And it's called this, and I'm going to change this to txt miles. That's the name of it. And I'm going to change this one to txt gallons. That's the name of it. And this is the LBL, because it's a label, miles per gallon. So those are the names of these things. And then I'm going to put a button here. I'm just going to put it, I'm going to have it display out an asterisk, just so I can know it's there, but I'm not going to. And then I'm going to put a button here just to say calculate. And on the button, I'm going to say calculate. And I'm going to name the button BTN calculate. Okay, so now I got this code here, and I'm gonna write the event handler for when you click on the calculate button. So to enter the code to click on the calculate button, you can just double click on this calculate button here. I'll double click, and right here is where I type in the event handler for the calculate button. Now let me just make it easier on myself. And I'm going to go over here, and I'm just going to grab this code. Can I grab this code? No, I cannot grab that code. So I got to type in the code. So I'm going to say try, single quote, enter, double miles, comma, double gallons, comma, or semicolon, double MPG, semicolon. Miles equals double parse, parentheses, txt miles dot text, gallons equals double parse, parentheses, txt gallons, and mpg mpg equals miles divided by gallons, semicolon, LBL, miles per gallon, dot text equals mpg dot toString, just that. Okay, so that's the try part, and then I'm going to do a catch, parentheses, exception, so I can see what the exception handler is, EX. The name of the variable is EX. This is the type. It's not important. And do that, and this says message box show, and I'm going to display out the exception. That's all. Maybe I better do toString. I'm not sure what kind of variable that actually is, so I'm going to do a toString just to make sure. Okay, so that's my code, and so let's run it. So if I went 100 miles and I put in 5 gallons, I get 20 miles per gallon. That's great. If I put in nothing, bung, this was not in correct format. The other thing is, let's do 100, and what happens if we put 0? Oh, that's right. With doubles actually has a representation in it for infinity. If you look at that symbol very closely, it's actually an infinity symbol. Let me make it bigger. I'm going to make this thing be much bigger. I'm going to make it 18. Now it's much bigger. Okay, so if we do this way, put 100, 0, calculate, it looks like an infinity. If we happen to make these things decimal, which we can do, that, and we run this. Oh, oops. I'm trying to parse it into a double, and they're decimal variables. Silly stupidness. This has got to be double. I mean decimal. This has got to be decimal. All right, no more squigglies. Go 100, 5. That works. 100, 0. Boom. Divide by 0, exception. Exception. All right. So that's that. Let's get back to this. Using named constants. Okay, so a number constant is a name that represents a value that cannot be changed during the program's execution. It's all it is it's a convenience for the program. Was 2 things. It's a convenience for the programmer because we have this interest rate, and let's say it's GET tax rate. You know, there's a GET in there, whatever it is, 4.7, whatever. And, you know, it's a constant. It's never going to change, except for maybe in 2 years it'll change. It'll change once, and then it's that way for 2 years. And so it's nice to have something like this where throughout your program you can call it by a name, and it'll convert over into what the value is. Declaring it a constant, doing that means once the interest rate, if something changes, you only have to change it one place in your program. Okay, so you only have to change it once in your program, and then every place where it's GET tax rate or whatever, it's going to be the new value. And the other thing is that when you declare it a constant, that means you can never change it inside the program. In other words, you cannot have interest rate on the left side of an assignment statement. The only time you can have it on the left side of an assignment statement is when you declare it. So you're declaring a constant here, and it's a double type constant. And we're going to call it interest rate, and we're going to set it to 0.129. And from then on, you're only going to see interest rate on the, I think I might have said the wrong thing. It's on the left side of an assignment statement. This is on the left side of an assignment statement. After this, you're only going to see interest rate in an expression on the right side of an assignment statement. So after this, you're only going to see it over on this side somewhere, multiplied by whatever. And then internally, in the computer internally, this still takes up memory. Still takes up memory. Actually, it doesn't. Actually, it doesn't take up memory. It's this kind of thing is embedded into the code of the computer. So, yeah. But it does not have to be in the RAM portion of the memory. You know, the RAM portion of the memory is memory that can change, and the program can change. So all your variables in your program are going to be in the RAM memory. This thing can actually be down in the program. It's going to be in the program memory. It's not the data memory, it's the program memory. And the program memory, once the program is there, it doesn't change. The program memory doesn't change. That's where all your code is. Your code is in the program memory. Your code translates into, you know, basic code of the microprocessor, and then it goes in the program memory, and it doesn't change throughout the life of the program. Whereas the data memory does change. That's the idea. The data memory's got all your data variables in it. It changes all the time. And this is just a convention that it's written in all uppercase. It's just a convention. You can do whatever you want. Okay, so declaring variables as fields. A field is a variable that's declared at the class level. So, I mean, I just call them variables, but I guess in C# we should distinguish between fields and variables. Variables you see inside the methods, whereas fields are outside, and fields can be accessible from outside the method. They can be accessible if they're not private. This one's private. So it's a little different than variables that are inside here. In this case, this is inside a method. This is a method, and these are variables, all right, but they're variables. We could actually make these fields by putting them out here, and it would still work. Private. I'll make them private. And all private means is you can't access it from the outside. And you'll know what that means more later. So this should still work. 100, 5, whatever. So and so just for now, just call them fields instead of variables. But if you call them variables, it's unless it's a quiz question. But I don't write the quizzes. I just use the quizzes. I read the quizzes. A field is a special type of variable. A field's scope is the entire class. You know, it's there for as long as the class is there, which is the entire life of the program. Whereas whereas variables inside methods, it's like the variables inside here. Let's just take one of them and put them in here for the heck of it. Let's not make it private. These two variables or fields are going to be around for the life of the class. This variable is only going to be around when the guy clicks the calculate button. The guy clicks the calculate button. This comes into existence. These calculations are done. Oh, by the way, this is stored back out here again. This is stored back out here again. This calculation is just stored there. And then that's written here. Okay. And then it's done. And this goes away when it's done because it's done. It doesn't need it anymore. This thing executes down to here, and then it's done. And then so that's one difference there. We'll see how that's important more later. So here there's a private variable called Charles. So we have this thing called, there are classes that, well, there's this thing called a math class, and the math class has got a bunch of functions in there that we can use. And like there's a square root function in the math class. There's a power, x to the y power. This is a constant, which represents the pi, 3.14159, whatever. This is e, which is 2.732, whatever e is. Just constants in nature. For graphical user interfaces, there's a tab order. There's a tab index. Here's what I'm talking about. Let's do a tab. Let's see what this is. This is tab order. Where's tab? Some tab is someplace around here. Tab index 3. This tab index 3. Tab index 4. Tab index 6. Okay, so when we run this, so I'm going to tab. Okay, it's sitting there. Tab. All right, that's what it should do. What if happens if I tab some more? Tab. Okay, so it's not gonna sit at the. It's just gonna go to things where there's an input. So we can change that. We can do. Let's start out here. Let's make this one a 1. I don't know if this will work. 1. Make this 2. Make this 3. Okay, now let's run it. Now it sits there, see? Tab goes up there, goes down here. That's tab order. To set the tab order of a control, click the tab order on the view menu. This is another way to set the tab order. You can just go right to the number and change it. Notice labels do not accept the input so they would never receive focus. So we're tabbing through things that can receive, that can be the focus of, where there's an input. We can also set the focus. So let's say we by just saying this. So we could start it out by saying, you know, whatever the tab order is, let's start out by making this be the focus for whatever dumb reason. So the way to do that is we do, when we start out, okay, so how do you make something start out something? Well, I think I'm getting ahead of myself here, but if you double click out here, I'm going to double click. This now is the event handler for when the form starts up. The form loads, and then all this code down here executes, and then it sits and waits for something to happen. So the first thing I'm going to do is I'm going to change the label, LBL, miles per gallon, text equals blank. That way it's nothing. And the other thing I'm going to do is btn calculate dot focus. That's all we do. So now when it starts up, the focus is going to be on the button, which is dumb because I don't want to click the button first. But anyway, let's do this. See what it does. Okay, so we start this up, and we notice the asterisk isn't there anymore. Why? Because I do. And also notice that the tab. Why is it? Tab should be here. Huh. I wonder if after it starts up, it actually goes to the first thing. Okay, this might not be right. I'm gonna instead put it. I'm gonna take that out. I'm gonna put it after this is done. I'm gonna say txt miles dot focus. So after it's done, it changes the. Let's see if this works. Okay, so you notice it's starting out gallons. So I'm going to go up here, and I'm going to put 100 tab 5 tab enter, and it's done, and it puts the focus back up here because that's the last thing it did. It put the focus back up there. So you can also assign this. I know this is a quiz question. So you can also make it so you just type letters and it tabs. It actually tabs to it. So like if you want to so this is how you do that. You put an ampersand right before the letter, and so this is going to make right here the text. So this is going to make on the exit button. So what we can do is here we can put this says calculate. Let's say we want to be weird and we want to make it so when you click the L button, when you click the L, it does the calculate. Okay, just to be different. So what I do is I put an ampersand right in front of the L. That. And it puts a little underline under the L. I'll make this bigger. Puts an underline under the L. And so now when I run it, it's all messed up. 100, no. 5, 100. Now if I click the L, hope this works. Do I just put the L or no, I got to do Alt L? Can't remember. Alt L? Oh yeah, Alt L. I did Alt L and it calculated. Okay, you know, we can set colors. We can, yes. Yes. Alt key. Alt, yeah. colors, pictures. Okay, this now we're getting into fancier stuff. Oh, and the debugger. Okay, you can set colors, forms, and most controls have a back color and a text color, and these are all properties. These are properties, and this is how you can set colors by, you know, you don't have to remember what the color code is for black or the color code for yellow. You just say color dot, the name of the name of it, and these are all properties that you see over here. See font color, for color, you know, I don't know, whatever. So that kind of stuff. There's a whole bunch of properties here, and we're only going to use just a very few of them. But sometime when you're actually writing, making a system, making something, then that's where you want to go in and check out all these different properties, all the ways you can make it different, make it unique, and have fun with that. All right, I think this is a good place to quit because next time we can get into pictures and then some of this other stuff. Using the debugger, that's a pretty important thing, and breakpoints, that's a pretty important thing to learn. And we can spend some time on that, where we can see how we can step through code and so on to see how things work. The watch window, locals window, that's all some stuff we need to spend a little bit more time on. So, are there any questions? All right. Yes.
Going back to that parse. When would you use the double parse? Like, I'm having a hard time understanding.
Okay. So okay, you use double or decimal because you want to take some text and you want to convert it into a particular number format, and then you want to store it into a variable. And the number format you want to convert it into is the number format of the variable. So because this is decimal, and then you're reading some text here, and you want to store that, you want to convert that into an actual a real number that the computer understands, and it's not the human form of a number, it's the computer form of the number. So you got this you got to say, and you have to say that you want to convert it into this kind, so then it's going to store it in here. If this was an integer, this was an int, then you'd want this to be int, because you want to convert it into an integer. Now, does this other stuff work? I think it does. I think it'll still work. Maybe you got to do, let's see if this works. It should still work. 100, 5. Yeah, it still works. See, so you want to, and parse, you can think of parse as like, in this case, you can think of parse as just convert.
So double is just to prevent like overflow?
Yes, double is the one for overflow, and double can store a real huge range of numbers. You can store it. It's
That way, whenever you divide by 0,
that's a feature of C#. I haven't seen that in any other language. So C# double range. See, the double goes from 5 times 10 to the minus 324 all the way up to 1.7 times 10 to the 308. And whereas decimal, see, it's not as big a range. It's only 10 to the minus 28 to 10 to the plus, but the numbers are stored as decimal. It's weird. This isn't really the binary number system. It's another kind of system where when it does the calculations, it actually does base 10 calculations. So that way, you know, converting from base 10 to base 2, there can be rounding problems because it's a conversion of, especially when you're doing decimal numbers. And so you if you want to avoid all the kind of rounding problems that you get by converting really small fractions from binary to decimal, because humans have to read decimal, computers got to understand binary in its basic language. You know, there can be some funny loss in precision. But if that's not important to you, really the size of the numbers is important to you, then you use double. But if it's important to you that you never have any loss if you're dealing with interest rates and people's money and stuff, and it's got to be just, you know, the human sees that number, it's got to be that number, then you do that. So it takes 128 bits. That's 7 bytes. 8, 30, whatever it is. It's 16 bytes or something. It's 128 divided by 8, whatever that is. It's bigger. I mean, this is what you use for characters. These used to be ASCII characters. Now we have Unicode characters, which is a bunch of other characters in different languages and stuff, and then double and decimal. So these are features of C#. There's not any other language that I know of. All right. So we will see you on next Tuesday. Thanks for watching.